Okay, so here we have our review packet and we'll make a key together. So you can fast forward throughout any of these slides if you want to get to a later slide that you want to know the answer to. Okay, so let's start on this slope. Do you see that we have this red line over here? It's going down from left to right, so we know it has a negative slope. Let's quantify what that negative slope is. Okay, so let's start at one of the points, and we'll start right here, and let's go down 1. So this is down 1. Do you see that this is a 4 and this is a 3? Therefore, from here to here is 1. Okay, we're going to ultimately try to get down to this point. So let's go 1, 2, 3, 4, 5. You see that we had to go 5 down. So our slope is change in y over change in x. So we went down 5 over, let's see how much we need to go to the right. Now so from here to here is considered 1, from here to here is considered 1. Okay, so here we go. So we're going to the right 1, going to the right 1, 2, 3, 4. So we went to the right 4, and that's in the right direction, the positive direction. So that's going to be a positive. So that'll be negative 5 over 4. So our slope is negative 5/4. The equation is y equals mx plus b. So in order to put that y equals mx plus b, we already know what the m is. The m is negative 5/4 x plus, and the b is where it goes through the y-axis, which is this point right here. Do you see this point is halfway between 1 and 2? So let's call it 1.5 or 1.5. So thus, the equation of this red line is y equals negative 5/4 x plus 1.5. Let's move on to the horizontal line in this graph over here. Okay, remember, horizontal lines are always having a slope of 0. So you could write in 0, or you could just write in 0. Okay, so you could write either of these. Now, what is the equation of this line? So you could put it in y equals mx plus b form, where the slope is 0. And then here, the y-intercept is down here at negative 2. So this is a perfectly fine thing. You could write that. You could also see that 0 times x just makes 0. So you could say y equals 0 plus negative 2. You see that 0 plus negative 2 is just negative. So you could also say y equals negative 2. So either of these are totally fine. Okay, I'll write in y equals negative 2 because that is a shorter way of writing the equation, but long story short, if you need to write the equation of a horizontal line, you write y equals, and wherever it goes through the y-axis, in this case, negative 2. And let's move to, oh, let's move to this section right here. The line through points negative 2, negative 6, and 4, 6. So we want to come up with a slope between those two points. Okay, so the way that we come up with slope is on the test, you should write down the slope equation. So we'll do m equals y1 minus y2 over x1 minus x2. Okay, and then you pick out which point you want to be point 1. So let's call this point 1. So this is x1, y1. And let's call this x2, y2. Okay, see how they match up with these points right here? Okay, so then if we're plugging it in, we'll plug in y1 is negative 6 minus y2, which happens to be 6, over x1 happens to be negative 2 minus x2, which happens to be 4, So we've got negative 6 minus 6, which is negative 12, over negative 2 minus negative 4, which is negative 6. So negative 6, so negative 12 over negative 6 is that negatives cancel out, and you're left with 12 over 6. Over 6 is 2, divides down to 2. So your slope here is 2. I'm going to put a slope in this 2. Okay? Now that you have a slope of 2, you need to come up with what our y-intercept is. Okay, so let me just erase this so we can have some more room here. So if we have our slope is going to be 2, that will be y equals 2x plus b. All right, now we just need to figure out what the b is. In order to figure out what the b is, we could plug in either of these points, either this one or this one, because both of these will balance the equation. So we could plug in, let's plug in 4, 6, okay? 4, 6. So 6 is the y, and then 6 here, equals 2 times the x with the x that corresponds to the y of 6 is 4. So put in the 4 and then plus b. All right, so this is 6 equals 8 plus b. Subtract 8 from both sides, and you get 6 minus 8 is negative 2, so you get b equals negative 2. Now that you have b equals negative 2, you've got the slope, which is 2, and you've got the y-intercept, which is negative 2. And you fill it in. Y equals 2x minus 2. So that's how you come up with the equation of the line that goes through points negative 2, negative 6, and 4, 6. We'll do the exact same thing for the equation we need to come up with over here now. Okay, so again, let's come up with the slope first. So our slope is going to be subtracting our y's over our x's. Okay, so let's call this x1, y1, and let's call this x2, y2. All right, so now we're going to just be subtracting our y's. So y1 is 3 minus y2, which is 0. x1 is 4 minus x2, which is negative 8. So now we need to figure out what that is. So m equals 3 minus 0, which is just 3, over 4 minus negative 8. When you have a minus negative, they cancel out to be positives. 4 plus 8 is 12. So you have 3 over 12, that reduces to 1/4. So our slope is 1/4. 1 over 4, quarter. Okay, now that we have our slope, now we need to figure out what our b is, our y-intercept. So we know that our m is 1/4. Our m is 1/4, so we can put that into our equation. So we have y equals 1/4 x plus b. Now to figure out what our b is, we can plug in either this point or this point, doesn't matter. Because either of the points lie on the line, so they'll help us balance out the equation. Let's plug in 0 for y, and let me write that a little bit nicer. So 0 is for y, and then equals 1/4 x, the corresponding x. If y is 0, the corresponding x is negative 8. So here's 1/4 times negative 8 plus b. Okay, so 1/4 of negative 8, 1/4 times negative 8 is negative 2. Okay, so we could erase this and make negative 2 right here. All right, so 0 equals negative 2 plus b. I'm going to get b alone, so we'll add 2 to both sides. And then b equals 2, right? So let me do that a little bit neater. 0 equals negative 2 plus b. Okay, just don't have a lot of room here. So 0 equals negative 2 plus b. So we have 0 equals negative 2 plus b. Add two sides, and you have b equals 2. All right, so now we have a slope of a quarter, and we have a b y-intercept of 2. So you put that into the equation. Y equals 1/4 x 2. Okay, so that's this page. All right, so here we have a graph and we want to draw a line on it. We know that the slope of this line is going to be negative 1/2, so it's going to go down from left to right. We also know that it goes through the point 4, negative 3. Remember, our first coordinate is always the x1, and then our second one's a y. So here, this is our x-axis and our y-axis. So let's go to 4, okay? Each one of these, see this is 2, this is 4, this is 6. So if this is 2, that means this needs to be 1, this needs to be 3, 5, okay. So we're going to go up to 4 on the x-axis, and then we're going to go down 3. So that's, this is negative 2, this is negative 4, so negative 3 would be right here. So then that's what we've got. That point right here is 4, negative 3, okay? So let me now use a different color. Okay, so we have a slope of negative 1/2. Okay, what does a slope of negative 1/2 look like? So m equals negative 1/2. By the way, there's a couple ways to write that. You could write it negative 1 over positive 2, or you could write it 1 over negative 2. They both mean the same thing. So that means that if we wanted to, we could go down 1 to the right 2. Let's do that. So taking into account that the scale, it looks like each of these squares is worth 1 here. You can't always assume that, but since we counted it out and we saw the which we're going down 2, we're going down 4, you can see each of these squares is worth 1, so that's fine. Okay, so let's go down 1 and then to the right 2. Boom. Down 1 to the right 2. Boom. Or we could have gone up 1 to the left. Let's go up 1 to the left 2. Boom. Up 1 to the left 2. Boom. Right? Now we have plenty of points. We only need to have 2 points to draw a straight line, but let's draw through all the points that we have since we did more than we had to. So that blue line represents what the line looks like. It has a point of 4, negative 3, and it has slope of negative 1/2. Do you see that the slope is going down from, if you're reading the graph from left to right, do you see that the line is going down? That means it has a negative slope, which checks out. Okay, so let's write the y-intercept. What's the y-intercept of this line? So it goes through right here. Do you see that? So that's at negative 1. So the y-intercept is b equals negative 1. So when y equals mx plus b, the b is the y-intercept, so here the b is negative 1. All right, here we have our first word problem in our review packet. I'll read it here. All tickets for a concert at the pageant are the same price. So the pageant is a theater down at the Loop in St. Louis. So MetroTix, which is a website that you can buy tickets online, but they do it for a service fee. Okay, so you can buy tickets to go to the pageant through Metro Tickets, their website, but it is going to cost you a fee. Metro Tickets adds a fixed fee to every order. Okay, so whether I buy 2 tickets or whether I buy 10 tickets, there's going to be a fixed fee that's associated with that order. A person who orders 5 tickets pays $93, and a person who orders 3 tickets pays $57. How much would it cost to buy 10 tickets? So let's assume that all these people are buying the same kind of tickets to the same kind of show, and that all the tickets are going to cost the same. And let's assume that the fixed fee that Metro Tickets charges is the same for everybody. Okay, so whether I buy 10 tickets or 1,000 tickets, it's still the same fixed fee. Okay, so let's say here, see that this is 5 tickets is $93. So let's make a coordinate with that. Okay, So 5 tickets costs $93. Okay, and 3 tickets costs $57. Now, why did I put 3 first, then 57? Why did I put 5 first, then 93? Because the number of tickets that I'm trying to buy, or these people are trying to buy, if you're imagining it on an X, Y axis, okay, the number of tickets would be our independent variable, and the price considered our dependent variable. Why? Because how much we pay depends on how many tickets we decide to independently buy. Okay, so that's how we can come up with these two coordinates, 5, 93 and 3, 57. Now we have 2 points, and if we have 2 points, we can create a line, the equation of a line, and y equals m. So the slope in these word problems is going to be the price of a ticket, or the price of a t-shirt, or the price of whatever you're buying. The b is going to be the fixed. So if you have 2 points like we have here, and you can create the equation of a line, then you can look at the m and figure out what the price is per unit, and you can figure out what the b is, which is the fixed b. All right, so now let's do that. Now, this is just taking skills that we've already learned. Let's say that you are just given 2 points, 5, 93 and 3, 57. Now, because of the word problem, we came up with those 2 points, but now that we have the 2 points, the rest of the skill is basically the same that you've already done even before you learned how to do word problems. Okay, so let's find the slope. The slope is y1 minus y2 over x1 minus x2. Let's call this point 1, okay? And let's call this point 2. And then if this is point 1, this is x1, y1. If that's point 2, this is x2, y2. Whoops, I should have written y here. y2. Got it? So now let's plug it in. So y1 is 93. Minus y2, which is 57, over x1, which is 5, minus x2, which is 3. Okay, so that's 93 minus 57 over 5 minus 3. 93 minus 57, I'm going to have to do that. Let's see, 93, 57. Carry the 1, that's $36 on top. 5 minus 2, that I can do in my head, that's 2. 36 over 2 is 18. That is the slope. The slope is the price. Price means that it's $18 per ticket, okay? So we can put, I'll just put an 18 over here. Okay, now that we know what the ticket price is, which is $18, let's figure out what the B is. We can figure out what the B is because now we have all of the numbers that we need to know except B itself, okay? B is the y-intercept, meaning the fixed fee. So if I didn't buy any tickets, then let's say I went onto the website. Even before I buy any tickets, I know I'm going to have to pay a fixed fee because Metro Tickets is going to need to earn money, and the way that they earn money is by charging a service fee. So no matter how many tickets I'm going to buy, they're going to charge me, the standard service fee. Let's take one of the points. Let's do 5, 93. Okay, so we have y equals 18x plus b. How do I get the 18? Because the 18 is the price of a ticket, or the slope. So each of these, sorry, I didn't mean to say that. Okay, so $18 is the price of a ticket. Okay, so all these tickets are $18. We need to figure out what the Metro Tickets service fee is, though. So let's plug in 93 for y and 5 for x, okay? So that's 93 equals 18 times 5. I got all my numbers in there, except I don't know what b is, but that's okay. I can now solve the equation for b. So I need to figure out what 18 times 5 is. Times 5, that's 45, 90. Okay, so that's 93 equals 90 plus b. I'm going to isolate b by subtracting 90 from each side, and 93 minus 90 is 3. So B equals 3. This is the fixed fee. That's what Metro Tickets charges you to buy tickets from or through their website. Okay, so now I have an equation. Y equals 18x plus 3. Okay, the cool thing by having an equation now is now I can use it to find out how many, what the cost will be of however many tickets I want to buy. So if I wanted to buy 10 tickets, for instance, I could plug that into the equation. Now, 10 tickets is our x, okay, because we're deciding to buy 10 tickets. So instead of writing y equals 18x plus 3, now substitute out the x and put in 10. Y is going to be my ultimate total cost. So I know that each ticket is costing $18. I want 10 of those tickets. So 10 times 18 is 180. Plus that fixed fee that Metro Tickets is going to have to charge me no matter what the size of my order is. So $180 in tickets plus $3 in service fees makes it $183 total. So if I want to buy 10 tickets off of, for this particular pageant show, off of Metro Tickets, I'm going to have to pay $18 per ticket, so that's $180 total in tickets, plus $3 Metro Tickets fixed fee, add that together, and it's $183 in total. So that's how you do this word problem. All these word problems are going to be the same. You're going to be creating these two sets of coordinates, figuring out what the slope is, and then the y-intercept, creating your equation, and then you can plug in any number for x and then figure out what that ultimate cost will be. All right, here we have another word problem. Here we're at a bowling alley. So a bowling alley has a shoe rental fee and a per game fee. George bowled for 4 games and paid $19. So that $19 includes 4 games and 1 pair of shoes. Spencer bowled 10 games for a total of $40. So that $40 includes 10 games plus that 1 pair of shoes. Write an equation to represent the relationship between the total cost C and the number of games G. Okay, so in this case, the number of games G is what each person decides to bowl, and then the total cost is what ends up is the dependent variable. So C is the dependent variable, okay, and G is the independent variable. Because G is the number of games that they decide to buy, and C is the resulting cost, okay? It's the resulting cost in total that is ultimately billed at the end of the night, okay? So you know how we have y equals mx plus b? Well, instead of y, which is our dependent variable, here we call our dependent variable the total cost for C. Instead of x, which we call the independent variable, here the independent variable is the number of games that we're going to buy. Okay, and then we still have our fixed fee at the end. This is the price of shoes. Price of shoes. Okay, so you multiply the number of games times so this is number of games. You multiply the number of games times the price per game. So M here, the slope, is the price of a game. G is the number of games. So if you multiply G, the number of games, times the price of a game, then you get the total cost coming from the price of the games. If you add that to your shoe rental, you get the total cost C for the entire evening. Okay, so this is the answer right here for the first one. C equals mg plus b. All right, given this information, how much should Jake expect to pay to bowl 8 games? Okay, but first we need to figure out what the slope is, the price per game. And then we also need to figure out then how much the price is to rent a pair of shoes. And then we can figure out how many 8 games would cost, because then you would just multiply 8 times the price per game. You would get some number, then add that to the cost of the shoes, and then there you have it, the total cost for your evening. Okay, so we first need to figure out what our slope is. Remember, we always need to come up with 2 sets of coordinates, okay? So we already said that G is the independent variable and C is the dependent variable. Okay, so let's look at George. So George is bowling 4 games, so that's independent variable of 4, and then he paid $19. So 4 comma 19 is a point, and then as you can guess, Spencer, 10 games, and it costs $40. So do you see that we have these 2 points now? Since we have 2 points, we can make a slope. So m equals y1 minus 2 over x1 minus x2. Okay, and let's call this over here x1, y1, and let's call this over here x2, y2. Okay, so here we go, and y1 is going to be 19 minus y2, which is 40, over x1, which is 4, minus x2, which is 10. Okay, 19 minus 40, that's going to be a negative number. It'll be negative, we'll be trying to do this in my head. That'll be negative 21. And then 4 minus 10 is negative 6. Okay, so negative 21 over negative 6, the 2 negatives cancel out, so you've got 21 over 6. Okay, so let's see what that means in real life. If you were at a bowling alley and the person at the cash register said, the price per game is 21 over 6, you'd be like, what does that mean? Okay, so let's convert 21 over 6 into something that makes sense in real life. Well, let's make it into a decimal. So 6 goes into 21. Let's see, it goes in 3 times, 18, 3, make some zeros, carry it down. 6 goes into 35 times, 0, 3.5, 3.5. Okay, what does 3.5 mean for a game? Well, the games are in dollars, so $3.5. What's another way to say $3.5? $3.50. Okay, so the price of a game is $3.50. That's what our slope is. Now we need to figure out what the cost of shoe rental is. Okay, so I'm just going to erase this, give myself some more room. Remember, I know that each game is $3.50. That's what my slope is. So I can plug that into the y equals mx plus b equation, okay? And that'll be y equals $3.50 x plus b, okay? Now, since I have 2 points, I can plug either of these in to figure out what my b is, right? I'll just, how about 10, let's do 4 and 19, those are smaller numbers. Okay, so if y is 19 and x is 4, you see I have all the information I need to then isolate b. Okay, 3.5 times 4, $3.50 times 4. That is, well, 4 times 3 is 12, and then 4 times 50 cents is 2. 12 and 2 is 14. So let me just make sure that I did that right. $3.50 times 4. So that's 0, that's 20, that's 12, 14, right here, $14. Okay, so I got 19 equals 14 plus b. I subtract 14 from both sides. 19 minus 14 is 5, so b equals 5. So what does that mean? It means it costs $5 to rent a pair of shoes for the evening. Okay, so now I can create an entire equation that represents what's going on here. So it's y equals 350x plus, and I just came up with shoes cost $5. So it's y equals $3.50 times x plus 5. Oh, and since we're using y as our we're using the cost as our dependent variable, let's use that instead of y. And since instead of x, we're saying g for games, the number of games. So we can plug it in like that. Okay, so now it says Jake wants to bowl 8 games. Okay, so we can plug that in. C equals 350 times the number of games, which is 8. And then for everybody, including Jake, it costs $5 to rent those shoes. Okay, so that's 3.50. Okay, so that's 0, 40, 24, 28. So that's $28 plus this $5. So 28 plus 5. All right, 28 plus 5 is $33. Okay, so the total cost for Jake to have an evening at the bowling alley will be $33. 28 of those dollars is for the actual games, and then $5 is for the shoes. $33 in total. All right, so here we are asked to analyze what's going on with an equation. Okay, the equation here that is given to us is negative 3x plus 5 equals negative 4y. Okay, as I have said many times, do not answer any questions about this equation until it is turned into y equals mx plus b form, or proper slope-intercept form. This is not in slope-intercept form right now, so we got to convert it into slope-intercept form, then we can answer any questions, okay? So why don't I write it down here so I have a little room. So it's negative 3x plus 5 equals negative 4. Okay, so what I could do, just right off the bat, is I could say, do you see that negative 3x plus 5 equals negative 4y? That's another way of saying negative 4y equals negative 3x plus 5. Aha. See, so this is still not in y equals mx plus b form, but it's a lot closer. Okay, now I have this negative 4 that's tagging on to this y. Okay, I need to get rid of that negative 4. How do I do that? Let's divide everything by negative 4. So every term on both sides we're going to divide by. Okay, so now we're left with y equals negative 3 over negative 4x plus 5 over negative 4. Okay, we can clean this up. You see that negative over negative makes a positive? So that negative 3 over negative 4 is really just like a positive 3/4 x. And then do you see plus negative 5/4? You can clean that up too and just say minus 5. So this is the equation that is in proper slope intercept form. Now, using this equation that I'm circling here in red, looking at that and that only, you can now proceed to answer questions. Okay, so let's go. And A, the y-intercept is negative 5. No, the y-intercept is negative 5/4. Cross that off. Okay, B, the graph of the linear equation has a positive slope. Yeah, 3/4 is positive. There's no negatives in there. So B. Let's see, what else? The C, the graph of the linear equation has a slope of negative 3. No, it clearly has a slope of 3. So we can cross C out. And D, the relationship between x and y is directly proportional. Okay, so directly proportional means that it is a straight line that goes through the origin, meaning the y-intercept would be 0. But here, the y-intercept is negative 5/4. Okay, so it's not directly proportional. This is a non-proportional line because it doesn't go through the origin. So B is our answer. All right, on this slide, it's asking us which ordered pair. So this is an ordered pair. These are all examples of ordered pairs. Okay, so which one of these ordered pairs is a solution to the line y equals negative 5x plus 12? By the way, what does a solution mean in this case? A solution means do these points lie on the line y equals negative 5x plus 12? All of the points that lie on the line y equals negative 5x plus 12 are solutions, okay? If a point is not on the line, it is not a solution. So we can plug in the x value and the y value of this point into the equation and see if it becomes an identity. If, when plugging in -2 for x and -22 for y, makes this equation an identity, then this point, by definition, must lie on the line because it balances the equation. If I plugged in -22 for y and -2 for x, and I come up with two sides of the equation that do not equal each other, something that's inconsistent, by definition, that point does not lie on the line. It's a point, it just doesn't lie on the line. So that's how you can tell if a point lies on the line or not. Plug it in, and if it becomes an identity, meaning both sides equal each other, it's on the line. If it doesn't create an identity, if it creates an inconsistency, like -1 equals 5, then you know it cannot be on the line. Okay, so so it's just a matter of plugging the numbers in and doing the math. So here we go. So -22 equals -5 times -2 plus 12. Okay, let's see what happens. So -22 equals -5 times -2 is a positive 10. Positive 10 plus 12 is 22. -22 will never ever equal positive 22. That is inconsistent, okay? So this point does not lie on the line, right? It is not a solution to the linear equation. Okay, let's plug in -28 for y and 8 for x and see what happens. Okay, -28 equals -5 times 8 is -40. -40 plus 12. Oh, -40 plus 12 does equal -28. Cool. So since this has turned into an identity, that we have proven that 8 comma -28, if we plotted that point on a graph and we plotted y equals -5x plus 12, if we actually drew that line, you would find that this 8 comma -28 would actually physically lie right on the line of this equation. Okay, so let's do the others because there might be more that also lie on the line, but maybe not, but we got to try all of them. Okay, so if 15 were y and -3 for the x, see if that turns into an identity. 15 equals, okay, -5 times -3 is a positive 15. So 15 plus 12 is 27. So 15 definitely is not 27. So that's inconsistent. So that doesn't work. Okay, last one, -2 for y and then 2 for x. Okay, plugging that in, -2 equals -5 times 2 is -10. -10 plus 12. -10 plus 12 is a positive 2. Positive 2 does not equal -2. So this is inconsistent. So the only one that was our winner was 8 comma -28. All right, so here we are plotting points. This is a pretty fundamental skill that we need for this chapter and later chapters, so we may as well iron it out right now. Okay, so very first thing that we got to do is make sure what our scales are on these axes. So this is the x-axis, this is the y-axis. What are the scales? If this is 2 and this is 0, then right between here is 1. Okay, so in this particular case, looks like we really are going up by 1. Okay, so it's 0, 1, 2, 3, 4, 5, 6. Oh, 7 here. All right, 8. All right. And then going up, this is also really important. You got to check if it goes by ones or something else. Because, well, this is a 2, so halfway between would be 1. Okay, so, and then this would be 3, 4, 5. Okay, I'm doing all this just to check that the lines, the notches really are going by ones, because on the test you can't assume that. So you need to actually, maybe the y-axis goes up by 5s and the x-axis goes up by 1. Okay, so that would totally change where points would be. Okay, but we see on this particular graph, we have shown that each square indeed is worth 1 unit. Okay, great. So let's go to A. So A is -2 comma -3. Here's the thing. -2 comma -3, we always do our x first, then our y. Okay. The first coordinate is the x. The second coordinate is the y. X comes before y in the alphabet. It's a way to remember it. Okay. So -2 is over. So -2 comma -3 would be right here. I go to the left 2 and then down 3, and that's I'll use blue for B. Okay, so B is 2 comma -6. So I go to the right 2 and then down -6, and I'm right there. That's where B is. C, I'll use green. I'm gonna run out of colors here. Okay, so that's 5. So I go all the way to the right for 5 and then up 4. And that is where C is. D, purple. 0, comma 2. 0, comma 2 is D. So 0 is the x value, so I don't go left or right, but I do go up 2 because that's the y value, so that's D. E is the next one. I'll do this orangey yellow thing. Okay, E is 2, comma 0. So I go to the right 2, but I stay right on the x-axis because the y value is 0, so I don't go up or down. So that's E. And then the last one is F. I'll use black. Okay, so F is -4, comma 5. So I go to the right 4 and then go up 5, and that's right here. And so that's F. And so we have plotted all of the points. Okay, so here we are figuring out what our slopes and our y-intercepts are given certain equations. These equations are not necessarily in y equals mx plus b form. So we need to get them into y equals mx plus b form first, and then we can see what the true slope and the true y-intercepts are. Let's start with the last one first, because this one actually is already in y-intercept form, so it's pretty easy. So the slope is right there, so that's 2. So I'll put 2 in for slope. And our b, or y-intercept, is 8. So I actually can do it right there because the slope-intercept form is already given for me. Okay, these other ones, I'm going to have to do some algebraic manipulation to get them into proper slope-intercept form, and then I can correctly analyze what the true slope and the true y-intercepts are. Okay, the name of the game is getting these into y equals mx plus b form. Okay, so here we go. Here, let's get rid of the negative x. So I'll add x to both sides. So now I've got 2y equals 6 plus x. Okay, now I need to get the y by itself, as right now being multiplied by 2. So I'll divide everything by 2. Okay, so that's y equals 3 plus 1/2 x. Okay, now I can rearrange 3 plus 1/2 x to be 1/2 x plus 3. And now I see that the slope is 1/2 and the y-intercept is, okay, let's go to the next one. So do you see that y is being multiplied by 2? You need to get y by itself. So let's divide everything by 2. So it's y equals x over 2 minus 2 over 2 is 1. Okay, now x over 2 is the same thing as saying 1/2 x. Okay, so the slope here is 1/2 and the y-intercept is -1. Okay, let's use blue for the next one. Here we have x by itself, but we want y by itself. So this is what we got to do. Let's, lots of things that we could do. Why don't we subtract 4 from both sides? So that's x minus 4 equals -2y. Now, if x minus 4 equals -2y, that means that -2y equals x minus 4, right? Now we've got negative 2y, but we want to get rid of that negative 2 because it's being multiplied against y. So let's divide everything by negative. Right? So then that's y equals, now x over negative 2, that's the same thing as negative 1/2 x. And then negative 4 over negative 2, 2 goes into 4 twice, and since you have those two negatives, it becomes positive. So plus 2. So you got your slope as negative 1/2, and you got your y-intercept as 2. And we've done all of them now. All right, here, so I've recopied our 4 equations from the last slide onto here so we can see them, and we're going to graph them all. Okay, again, really important, just want to point out that all of the squares here are worth a 1. You cannot assume that, but since I looked at it and I counted it out, I saw that each of these squares is worth 1. Okay, let's graph the red equation right here first. Okay, so our y-intercept is 3, so I count up 3, 1, 2, 3. And then it's a slope of 1/2, which means I go up 1 and then to the right 2. Up 1 to the right 2. Up 1 to the right 2. Okay? And so I can just draw. I don't have a ruler, so you'll have to excuse that my hand was kind of shaky. So, but that's what that red line looks like. Okay, let's go to the green one here. So we have a y-intercept of negative 1, so we go down here, so that's a y-intercept of negative 1, and then our slope is 1/2, okay? So we go, again, up 1 to the right 2, up 1 to the right 2. Or, you see that the slope of 1/2 is the same thing as the slope of negative 2. It's two negatives, positive. So if I wanted to, I could have started here and then at the y-intercept and go down 1 to the left 2, down 1 to the left 2. You see when I'm counting out the slope, I'm always starting from a point that's on the line. Very important to do that. Start from any point that's on the line and then you can count it out. Don't assume that you start at the origin. The origin may have nothing to do with anything. If the line doesn't go through the origin, don't start at the origin. Only start with points that are actually on the line, okay? Blue equation, we have a y-intercept of 2, which is right here, and then it goes slope of negative 1/2. By the way, a slope of negative 1/2 is the same thing as negative 1 over 2 is the same thing as 1 over 2, okay? So I could go down 1 to the right 2, down 1 to the right 2, or I could have gone up 1 to the left. Doesn't matter. Up 1 to the left, okay? So that would be my full design, all right? And then for y equals 2x plus 8, so 8 is going to be my y-intercept. It's all the way up there, and then it's a slope of 2. Okay, do you see that slope of 2 could be rewritten as 2 over 1? You can always write a slope if it's a whole number. You can always write it as a fraction just by putting it over 1. Okay, so we have a slope of 2 over 1. You see that if I try to go up 2, I've run out of space, like the graph is ended. So unfortunately, I can't go up 2 to the right one. But you see that negative 2, that positive 2 over positive 1 is the same thing as negative 2 over negative 1 because two negatives equal out to cancel out to a positive. So you could think of it as a negative 2 over negative 1 slope. So now I can do that. So now I go down 1, down 2 to the left 1, down 2 to the left 1, down 2 to the left 1, down 2 to the left. See, I can get all my points like that. Those are plenty of points to draw a straight line through. So these are how you graph all of these lines. All right, so the name of the game here is we're given a story or a word problem, okay? So it's just a scenario that's written out in verbally in words, okay? And what we're doing is we're trying to represent this relationship which is given to us as a story, and we want to create a graph out of it, we want to create an equation out of it, and we want to make a table out of it. So at the end of the day, that's all we're doing. We're just showing a relationship between two variables in all of these different kinds of representations, okay? And these representations are all getting to the same thing. They are all showing the same relationship, whether it's a table or a story or a graph or an equation. Okay, so here we have Jerry drives a Snapple delivery truck to supply restaurants with drinks. The Snapple drink factory where he loads up is in St. Louis. One day, Jerry is stopped in his truck at a truck stop on Highway I-70 between St. Louis and Columbia, Missouri. When he gets a call on his cell from a restaurant in Columbia requesting that he delivers that restaurant in Columbia a shipment of Snapple. The restaurant is 100 miles west of the truck stop on Highway I-70. So um, let's draw just a little bit of a picture. Okay, so let's say that this is St. Louis, STL. Okay, and then I-70 is a highway. Okay, drawn by this line, and we're gonna draw it west this way until we get to Columbia, and so we'll call this Columbia. Okay. So that's Columbia and that's STL, St. Louis. Okay. And they are 100, let's see, the restaurant is 100 miles west of the truck stop. Ah, okay. Now we have a truck stop involved. So let's just figure out where the truck stop is. Let's read on. While Jerry usually needs to restock his truck with Snapples at the drink factory back in St. Louis, he luckily already has enough Snapple in his truck to make a delivery directly to a restaurant. The truck stop is located 20 miles west. In this case, left is west, okay? 20 miles west of St. Louis on Highway I-70. Remember, this line right here is I-70, okay? And since we're 20 miles west, let's say that's right here. So this is 20 miles distance, okay? I'll do TS for truck stop, okay? So Jerry is at the truck stop right here. Circle that in red. So he is right here right now, okay? We're 20 miles to the west of St. Louis, and we're 100 miles. We got 100 miles to go to get to Columbia, okay? So from here to here is 100 miles, okay? So do you see that the distance between St. Louis and Columbia is 120 miles? Okay. So let's assume that the 120-mile stretch of highway I-70 between St. Louis and Columbia is a perfectly straight highway, and that Jerry starts driving as soon as he gets the call, and that when he is driving to Columbia, he's driving at an average speed of 50 miles per hour. Complete the table's Y values that go with the above story. Okay, so the time measured in X hours starts elapsing right when Jerry gets the call. Okay, and X is time in hours and Y is distance in miles from St. Louis. So do you see that the truck stop where he gets the call is already 20 miles west of St. Louis? So at time zero, like the moment that he gets the call at the truck stop, he's 20 miles away. So we're gonna write in 20 miles here, 20 miles. Okay. Now, since he's going 50 miles per hour on average, well, let's say in an hour. Let's go straight to an hour. In 1 hour, if he is driving at 50 miles per hour, he will have driven 50 miles from the truck stop, okay? So if he's driven 50 miles from the truck stop in 1 hour, so around here would be mile 50 from where I have this red thing. So if he has driven these 50 miles in 1 hour, he is 50 plus 20 miles away from St. Louis. So 50 plus 20 is 70. So in 1 hour, he is now 70 miles, just 1 hour of driving from the minute he gets the phone call. He's now 70 miles away from St. Louis because at time zero, at 0 hours, he was already 20 away. So in 1 hour, he'll be 50 plus 20, which is 70. Okay, so if he goes 50 miles per hour, that means he goes half that in a half an hour. So he goes 25 miles in a half an hour. Okay, so let's go back to this half hour here. So if he goes 25 miles driving in a half an hour, and he's already 20 miles away from St. Louis to start with, then he's 20 plus 25, which is 45. So at half an hour, he's 45 miles away from St. Louis. Okay, so we see that every half an hour he is going 25 miles further away from St. Louis. Okay, so then we can just use that pattern. So if at 1 hour he's 70 miles away, then at 1.5 hours, a half hour more, he's 25 more miles away. So 25 plus 70 is 95. And then in another half hour, he's another 25 miles away, and 25 plus 95 is 120, which means if he's 120 miles away from St. Louis, that means he is in Columbia, so that he arrives in Columbia. And so that is how we fill in the table. Okay, so I know that the table isn't on this sheet right here because we're on a PowerPoint slide, but if you can imagine back to the table, we had an X and a Y, and we had, remember at time 0, so at time 0, he was already 20 miles away from St. Louis. He was at the truck stop. He had a head start, so to speak. So that means that at time 0, we're at 20, a distance of 20. So I'm going to put that red dot on the graph right there. Okay. Now remember, he's traveling every half hour. He goes 25 more miles, right? So at a half an hour of driving, he's 25 more miles further away from St. Louis, and 25 plus 20 is 45. So at 0.5 hours, or a half an hour, he's 45 miles away from St. Louis, which is going to be right about there. Okay. All right. Now at an hour, he's another. Another half hour later will be 1 hour, and so that's 25 more miles. 25 plus 45 is 70. So at 1 hour, he's at 70 miles, which is right here. It looks like my other point disappeared. I'll put it back in, which is 45, which is about right there. Okay. All right. Now at 1.5 hours, so that's a half hour more. So each half hour, you travel 25 miles further. So that's at 95 miles. So 1.5 and 95 would be like right. This is 90, so 95 would be right there. And then ultimately at 2 hours, he arrives in Columbia, which is 120 miles away. But 2 hours, that's 120 miles. So there you go. And now you can, since we plotted those points, you can draw, oh, that's a terrible line, but assume that there we go, that's better. I don't have a ruler, so that's the best I can do, but on this test you'll have a ruler. Okay. So that's what the graph looks like generally. So write an equation in slope-intercept form that represents the story. Okay, so do you see that slope-intercept form is y equals mx plus? So where is he starting? At time 0, where is he? He's 20 miles away from St. Louis. So we know that the b, or the y-intercept, is at 20. So that we can write. So plus 20, okay? Now we just need to figure out what the slope is. The slope is m, and m, in this case, is his speed. How far he goes. The steepness of this slope is his speed, how far he goes each hour. And we're told that he's going 50 miles per hour. So put it in right there. So y equals 50x plus 20 is the equation in slope-intercept form of the relationship that we're trying to describe. So we have the equation, we have the graph, we have the table, and that all came from our word story problem.